So that's the trig stuff, right? What else are we worried about?
When can we use our calculator?
I'm going to let you use a calculator for most of it. There's going to be one small piece, possibly. I haven't really decided yet. There might be a part one where you can't use it, and there's going to be like maybe 5 questions on that. You know, mostly like trig stuff and all kinds of stuff. Some other simplification stuff that you should be able to do without a calculator. And then the rest of it you just use a calculator for. Even if you can use a calculator, I need to see work still, right? Okay. I have a specific problem I definitely want to go over with you in a certain way. I want to show you something. I'll show you 2 things that are really cool on the internet. Series of tubes delivering information. Anything else you guys want to focus on specifically? Yes.
So for question 12, you want us to create a table as x approaches pi over 2. So the best way, probably the best way to attack that is just create fractions that would approach x as close as possible.
You could do pi divided by 2, which everybody should know is roughly 1.5 something, right? 1.57. So then just approach 1.57 from both sides. Do you see what I'm saying? So you can go 1, 1.5, 1.57. 2, 1.7, whatever, right? I did a specific little table on the answer key, but tables could have looked totally different from mine as long as they're coming closer to it from both sides. That idea of the limit agreeing from both sides. I like it. And of course, you know, having the calculator on the wrong mode sucks so bad. Yeah, so just be careful about that, yes.
So for like, okay, so for 14, the tangent line with the horizontal, so you just want to, so we find the derivative, right, and then solve for x.
Set it equal to 0.
Yeah, so
yeah, now let me tell you this. I've been known to ask a question like, find where the slope is 2. In which case you just take the derivative and equal it to 2 instead of 0. So if I say find the horizontal tangent line, that's another way of saying find where the slope is 0. That's why it's horizontal. I could certainly say find where the slope is 2 or -7 or whatever the hell I want to, right? It's the same idea, you just set it equal to whatever I want the slope to be, specifically. Does that make sense? Yes?
I'm still kind of confused for 5 how to use the squeeze theorem.
Okay, so here's the idea. Whatever the function is that I give you, if I'm telling you that the squeeze theorem will work, there has to be a piece of that whole thing that I can just automatically write lives between this and this. So almost always it's going to be trig functions, but there are other functions that have ceilings and floors, right? So for this one, the sine of who cares, the thing I don't understand is students sometimes think that this changes what the outcomes can be. And they change what the specific outcomes are, right? If I put a pi over 2 in here, I'm not going to expect to get 1 necessarily because this is doing all kinds of weird shit. But the outputs still have to live between -1 and 1. I mean, I don't care what's inside. It doesn't change the range. It only messes with the domain, right? So where does sine live between -1 and 1? I love it when people bring their kids to class. I'm like, oh, I gotta be careful. I ask people to bring them headphones. Now, is that the function they're asking me to look at? Is this cool so far? You can find a piece of the whole thing that is contained. Now I multiply by whatever pieces I don't have, and I don't have the x minus pi cubed, right? And now I just apply the limit. Right, so if I apply the limit as x goes to pi, what happens on the ends? The ends go to 0, and the middle is just the limit. I'm applying the limit to it. So now I've got the question recreated here in the middle. See, there's the question. But now I know that the answer is between 0 and 0. So it has to be 0. The only thing that's between 0 and 0 is 0. It's really weird, but this kind of proof, not just squeeze theorem, but there's, more involved proofs that deal with this kind of thing. Look at it from one side, it's got to be greater than equal to 4. And the other side says it has to be less than equal to 4. So then the damn thing has to be 4. I mean, that happens in very many places, that type of thing. This is one of the most basic examples of being caught between the same thing. So then you must equal that. I like it.
Did you do like one of the epsilon problems?
Yeah. Well, I mean, I did. But I think the main thing people are curious about, some of you didn't know what to do on the problem at all, but a decent number of you kind of knew the idea, you just weren't sure about the formatting and which direction to go in, and when were you done with it. The main things that I need to get down, that's beyond just the calculations, right? You got your side work, blah, 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 and you get delta, right? And that, I don't even have to see that. You can do that on scratch paper and not even show it to me. This is not a part of the proof. It's just you doing your shit to know how to write the proof. So the proof would be given epsilon greater than 0, let delta equal to whatever. Right, normally it's epsilon over A. If you've done some of these, then you know what I'm talking about. With lines, it's unfortunate that the minute you make it any more complicated than a linear function, it gets really complicated. Because with lines, it's just going to always be epsilon over the slope. I don't know if you guys have noticed that. So if I have 3x minus 7 as my function, it's going to be epsilon over 3 that I want to use. Blah, blah, blah. I still want to, so you get there. Then, if x minus, well, I'm using a in a few different places. Damn it. X minus x1, whatever the thing is I'm approaching, is less than delta. Then replace delta with what it is. And then you try to get to here. If I am this close to my x value, then my outputs have to be this close to the limit. If I can do that no matter what epsilon is, they can make it as close to the limit as they want to. I can always find something that keeps it that close. That's the proof that it's the limit. And sure enough, whatever epsilon they give me, I just divide theirs by a. I can do it forever. However tiny you make your epsilon, I got it covered. If you can't do that, if your side work leads to nothing, then it's not the right limit. It's the wrong limit. Too bad for you. Yeah.
Has it ever not been the slope?
Well, for any linear function. So if the thing was the limit as x goes to x1 of ax plus b equals L, delta is going to be epsilon over a. That's what it's got to be. Because you're going to divide by a to get x minus x1, right? You got to divide by a. In that side work, you're going to get epsilon over a. Do you have to know anything I just said ahead of time? No. But it's an interesting little thing to realize. It's when this function is not linear that it's not that. It's going to be something much more complicated, like almost too complicated to discuss. That's the one bad thing about this. This is too easy in some respects. Some of you guys are like, what the shit are you talking about? I don't understand this at all. But the minute I try to make it a little harder, it's like, make it a little hard, boom! It's like, holy shit, that's way too hard. So if you've read any of the examples for things that are not linear in that section, you see what I mean about, you got to pick this minimum of these two, oh my God. I'm not saying it's possible, I'm just saying it's quite a bit more complicated. Yes?
So if that's on the test, you'll probably use a linear function for it.
Yeah, there you go. What I'm really curious, and what I'm really wanting to see is just, can you get the feel for the form? Proof writing is all about, here's the form of a certain type of proof. Do you understand the form? And then do you understand when to use which form? This is not a proof writing class. We have one form of a proof. But I like the little baby step of, here's a form of a proof. Can you get used to it? Can you write the form of it? Because then if you ever do have to take a proof writing class, you're going to learn this kind of proof looks like this, and this kind of proof looks like this, and this kind of proof looks like this. If this one works best in this situation, this one works best in this, blah, blah, blah. Here's a problem. Which one do you want to use? Can you write it correctly? I mean, that's... Yeah, okay. And believe it or not, there are plenty enough forms of proofs to have a whole class about. We're not going to do that. I have enough calculus to do. Yes?
So I'm still a little confused about 3C. Without a graph, it's a little difficult for me to...
3C?
Yes. Without using a graph. It's a little hard for me to understand this.
Oh, wait, so we're talking about the limit as h goes to 0, that one?
From the positive, from the top?
Yes. So, what do you try when you see something like that? What algebraic thing do you try?
Well, I would want to plug in 0 for h.
Yeah, and you see that that leads to, what does that lead to?
Leads to -2.
Yeah, but -2 over
Oh,
0, right? Because h is in everything on the bottom.
oh, right.
So, in the homework, this happens a lot. The answer is going to be, does not exist, but that's not good enough. I don't want to see that shit. The answer would be infinity or negative infinity for a few problems. So, for example, the easiest example is, what's the limit as x goes to 0 from below of 1 over x? X goes to 0 from below. So what kind of numbers are you plugging in for x? Negative numbers. 1 divided by a negative number is still negative. So the answer to this would be negative infinity. Whereas if I went from above, it would be positive infinity. So that's a really simple example of the idea that we're using. I can't tell with all the shit that's in there which infinity it's going to be necessarily. I can simplify that though. Now, to be honest, you don't necessarily need to simplify it, but if you do, it just makes it easier to look at and think about. Because you can factor the bottom. Yeah. And then parts of it will cancel, then you have a lot less shit to look at to figure out what's going on. Oh, is this me? Oh. Anything else from... Real quick, I want to show you a couple things real quick. Not Windows. Look, it's Windows. Okay. Two things. One of them you really should know about by now, but there's something called Desmos. You guys know about Desmos? Okay, now watch. Then I'm going to show you another one that you do not know a damn thing about. It's just really out of curiosity. So, for example, the which problem was it? Oh, number 16, the very last problem on the practice test. Watch this shit. Get ready for this. This is Desmos, D-E-S-M-O-S. If we had enough computer labs on campus, I would love to teach a lot of math courses in them using this. I mean, it would be so much better than the stupid little TI. To be honest, a TI is just stupid. It's like, who's going to carry around this once you graduate? No, you're going to use whatever software you've got at whatever job you end up at or whatever, right? So this would be a little more closer to reality instead of this thing. I mean, don't get me wrong. I'm a math guy. I love the freaking hell out of it, but it's still not the best thing to use here. So this function was x to the third. I'm going to just attacking that shit. Look, I love this. This program is so much better than identified already what it knows is good key points. That's the minimum there. Calculate that for me. That's the intercepts here and here, right? All right, that's amazing by itself. That's really cool. It's easy to zoom in and zoom out. Now here's the other level that I think will make you guys use the hell out of this. Let me see if I remember how to do this. I probably should try this earlier. Yeah. There's the derivative, f prime x. And then if I wanted to, I could do f double prime x. Makes sense? A cube, the first derivative should be a square, and sure enough, that blue line is parabola. And then second derivative should be a line, and sure enough, that green is a line. Let me take that third thing out. That's it. Go. Because this is what that problem relates to. Why does all this make sense? Well, the slope of the red line between 0 and 2 is positive or negative? Slope between 0 and 2 is negative, and sure enough, this is negative, right? The values of the parabola are negative in there because that's supposed to represent the slope. And then, of course, it goes to 0 where the slope flattens out, and so forth. You guys with me? This is an awesome tool just to get a nice visual. It's a lot nicer looking than it is when you graph it in there. And it's really easy to get derivatives. To be honest, you can get the derivative graphed on the graphic calculator also. It's just a little bit layered and hidden. This is a plug it in, you got it. What else I want to show you while I'm doing this? I can't remember. There was one other thing, but oh well. The other thing I want to show you, which will become more important if you go in much further in calculus. Wait, what was it? Plot.ninja. Pretty sure that's right, yes. One of my students, I think 2 years ago, 2017 was 1.5 years ago, Nick, he was a computer engineer, and he's also in my 281 class, which is basically calculus in 3 dimensions, right? Yeah. He came up with this. It's so much better than Wolfram Alpha for graphing 3D functions. Anyway, do you have to use this for this class? Not really, no. It's just really cool to see that. I'm hoping at least 1 or 2 of you would be like, I want to play with that shit. I want to go home and just plug shit in and see what it looks like. The rest of you are like, too much shit? What are you talking about? All right. I still don't remember what else I want to show you here. That's too bad for me. There's all kinds of stuff you can do with this thing. It's insane. But anyway, I'm going to let you guys play with Desmos if you want to. I told you guys yesterday to come ready with questions. I'm a little concerned. Most of you guys came ready to listen to questions.
So 15.
Yes.
I don't know why like the wording is making me a little bit like confused on how to approach it. I mean, I know what the tangent line is, so what we are trying to find is
The equation of the line. The equation of the tangent line. Right? So another way to say that is the equation of the line that is tangent to that curve at x equals 2. Yeah. So I need 2 things, of course. I need the slope and the point. Yeah. Mm-hmm. So you got x equals 2. You can plug that in. You can get to the rest of the points. You can do calculus to get the slope.
oh, okay.
Yeah. Yes.
Is the test gonna be this line?
So I said earlier that this is longer than it's actually going to be. If you looked at this whole thing, you can see it's a little repetitive. There are certain ideas that are sort of repeated throughout because I want you to think about that same idea from different angles. So the actual test is going to be tighter than this. Here's exactly what's going to be on the test. Anything at all from what we've done. I love it. In statistics, when I teach it, I tell them exactly a certain question that's going to be on every single test. The answer is always the same answer. We go over it, and then over half of them don't get it right. So I'm like, what can I do? I don't know. So, no, I'm not going to tell you what's going to be in the test. It could be any of this shit, anything from the homework. But it's not going to be this long. right? It's not going to be quite this long. Yeah, I do give you 2.5 hours to do the test, but I don't design it to take that long. Okay. I think I remember. What was that one? That one we just were talking about? X cubed minus 9x, right? Number 15. And if you do the work, did anybody do the work for number 15?
Yeah.
What'd you get?
3x squared. Oh wait, I like the derivative.
For the answer. The equation of the tangent line. I don't know if anybody did that yet. So let's do it. Let's do this problem. How do I do this problem? Oh yeah, by the way, you missed all that stuff. I'm sorry. I need to hire somebody to deal with my camera. So I've got this function. And then I got at a point x equals 2, I'm going to find the tangent line. So of course, I need the point. So the point would be 2 comma, plug that thing in, right? If you do that, you get 8 minus 18, negative 10. And then you need the slope. So we need to do what? Take a derivative. And I want the slope at 2.
3.
Yeah, so you get 12 minus 9, 3. And now you just plug it into your favorite thing. You can do mx plus b and solve for b. You can do y minus y1. I sort of am pushing this guy because it relates to something we do later. So you get y equals 3x minus 6 minus 10 minus 16. Now, if I graph both the function and this, we should be able to see this idea. So watch. Here's one idea by itself. If I take any point, even this little curvy point at the very top, if I zoom in enough, what should happen? It should start to look like a straight motion. There's the surface of the Earth. Yay! Okay, let's come back out. Oh my God, I forgot how to do this fast. I haven't used Desmos enough in recent. Okay. All right, so let's put this supposed tangent line in here, 3x minus 16, and its tangent at 2, negative 10. Oh, why are y'all orange? Oh, well, it's good. It's all right. I don't want it to be orange. I don't want it to be orange. Let me see. There you go. Trick it into the... Okay. So if I zoom into this point, you can see it already looks like the tangent, but if I zoom in, if it really is the tangent line, then they basically should become the same, only should. Okay. So that's that idea about when we did the square root and we figured out the tangent line and we used it to estimate the value of the square root at points near. This is the reason why. If you zoom in, that line and the straight line that it starts to look like, they have to be the same. That's the real, true idea of the tangent line. It has to act like the curve does, locally, perfectly. And that's basically what that's showing. That's nice. So, I mean, that's another thing you can do is just verify your answers make sense. You can graph them very quickly on Desmos and zoom in and see that they make sense. That's another way to use this. All right, let me go ahead and give you guys the answer key. Whoa. There we go. There's 2 parts to it, obviously. This thing is long as hell. right, make sure you get both parts. There should be one with nothing but blue ink, front and back, and one with a little red ink at the end. And the last problem, should have both pages. So you can kind of look that over. Now again, I think I said this the other day, but just don't look at this and agree with me, right? Because I would have done that. Yeah. That's building up false confidence. And don't overdo the problems on the practice test. Do them a couple times and then forget about it. Because then you're getting way too connected to that problem and not the idea. The idea is what's important. I grade that same way. I grade concept heavier than answer correct. That's why I don't do Scantron. Scantron is bullshit for math. Don't get me wrong, I'd love it if I just would let go of that. It'd be so nice to just feed it in. You're done grading. Oh my God. Yes?
So I have a question that's kind of related to the exam. So I've seen a different way of finding the limit within a linear function where they take the limit of each polynomial and then they do grade that way. And I thought it was very strange instead of just plugging in that limit value for.
So can you give me an example or?
For example, the function is 4x cubed minus 2x squared plus x minus 3, and the limit is approaching 2.
Oh, yeah, okay,
and
okay.
Taking each.
Yeah, I know. That one section makes it sound like the directions want you to write all the little rules, but it's really stupid. If it's continuous, we know this now, so we can be better than the little specific things. This is a continuous function for damn sure. It's polynomial. Everywhere it's beautiful. Which means that the limit as x goes to 2 is equal to the function value at 2. That's why I can just plug a 2 in and get the answer. Is that cool?
Is that 2.5 that you were saying?
Oh, it was a long.
2.3, I think is the limit laws. 2 point. That section that had all the limit laws, and they want you to identify the laws you're using for every step.
Oh, okay.
Yeah, it's great.
But the reasoning behind that is if the function isn't continuous, that would work, right? So the limit law would apply to that.
So, for example, if I had the limit as x goes to 4 of x squared plus 1 over 4 minus x, right? So I could do the limit as x goes to 4 at the top over the limit as x goes to 4 at the bottom. Right? So of course this limit is 0, which leads to a problem, right? The most important thing that comes out of the limit laws, so this is continuous everywhere on its domain. 4 is where this thing is not in this guy's domain. So that's where this would kind of lead to a problem. You end up with something that doesn't make any sense. So really the limit of this should just be seen as finite divided by 0, right? And in fact, all right, this one specifically, can somebody tell me what the actual answer is to this? So it's not infinity, just to make you aware. And that doesn't mean it's not some kind of infinity, but it isn't, to be honest. What does this mean? Limit as x goes to 4. What does that mean by itself? Yeah, the values approach 4 from both sides. So if I approach 4 from below, the bottom is positive. 4 minus 3, 4 minus 3.5. If I approach 4 from above, the bottom is negative. So they don't even agree on how they don't exist. It doesn't exist. This doesn't exist, but I can say it's infinity. But this shit, they can't even agree on how it's not existing. So this one just, it definitely does not exist. You don't want to say just infinity because that's not right. One side says negative infinity, the other side says infinity. How could you be any more in disagreement than that? Holy shit. Irreconcilable differences. So be really careful when you want to say the answer is infinity, stop yourself for a second and really look at it closer. Right? I don't know if that really answered your question, but the only reason they show you those limit laws is so you really are aware of the flexibility that limits have. But then later in the chapter, when we learn about the continuity, if it's continuous, then it's equal to the limit value there. That's why this kind of thing is stupid to apply the limit laws to. I just put like a 2 in the function because that equals its limit there because it's continuous everywhere. I like it.
And so, for example, that's what we do on the practice test for 6. Right? We can do something like that to prove.
Yeah, with 6, both of those functions separately are continuous everywhere. They're continuous on the domain, which is all real numbers, right? Each of those functions. The only place where it could be discontinuous possibly is at the transition point, right? So therefore, all you got to do to show it's continuous everywhere is show that it's continuous through that point. Show that the limit from below is equal to the limit from above, meaning show that the functions agree at the for the output at the input.
There was one problem from, I think it was like 2.5, where it say like draw a function that's only continuous on the right side of like x equals 2 or something. So how would you draw something that's like not continuous always on the other side?
Oh, do you remember which one that was?
Uh,
It sort of sounds familiar.
It was like 2.5, I think number 5, page 124.
Oh, okay. So when I say continuous, I needed to see how they phrased it. When I say continuous from the left or the right, that means it doesn't matter what happens on the other side.
Okay.
So this function, is it continuous at 2, this function?
Okay.
No. But is it continuous from the right? Yes.
I just took it as like it can't be continuous from the left if they want it only continuous from the right. So I was like, how do I draw the whole other side of the graph? But it can be continuous.
You can actually just, there, that's discontinuous from the other side, but it's not, so you can't do this because if it ends and it doesn't even exist here, I only consider from the side where it exists. So this would not be discontinuous at this point. It's continuous at this point. So you'd have to draw something like this. It's discontinuous from below, but it's continuous from above. Remember, continuous means you have to reach the value that it looks like you're going towards. So this this continuity matches what they're asking for. Does this reach what it looks like it's getting to? Going towards? No. This one does. So that would be discontinuous from below, continuous from above at that point. I like it. Now please, do you understand the difference between, it's like the limit from below, the limit from above? Right? Doesn't the limit from below exist? Yes. And doesn't the limit from above exist? Yes. What's the limit at 2? Mm-hmm. So continuity requires the limit from both sides to agree, and it actually gets there. Continuous from the right, I only care about it looks like it's approaching and it gets there. Continuous from the left, the same idea. So it's just like limit from below, limit from above. Makes it a little less restrictive. Is that decent? So is the square root function, is it continuous at 0? Yes. It's not. It wouldn't be fair to say no because it's not. No, because it doesn't exist back here. So here we only consider it from that direction because it doesn't exist on the other side. It's a little unfair then. Poor little dude. So we say that this is continuous at 0. Okay, remember what that theorem says. The rational functions are continuous everywhere on their domain, and 0 is certainly in that guy's domain. Okay. Do you guys... the hardest problems on this normally for people are like number 2. Number 3, I'm hoping, I mean, number 1, I'm hoping is not a big deal, although a lot of you guys missed that problem in the homework about draw the inverse of that little thing that looked like an elbow. They give you the function that looked like an elbow. Some of you guys just were like, I don't want to deal with that one. I'm just going to move a line around. No, you got to deal with the function they gave you in the problem. You guys know which one I'm talking about? It looked like this or something. Remember that? And you had to move it around and shit. And you had to reflect it. And you had to do the inverse and all kind of stuff. So to find the inverse of a function, you just switch the x and y. I love it. To do it visually, you switch the x and y and regraph it. To do it algebraically, you switch the x and y and solve for y. I mean, it's just switch the x and y. It's a beautiful thing about it. Yes?
On that question, you said you can graph the inverse because it passes the horizontal line test, but I put it's because it's a one-to-one function.
Oh, okay.
Would both of those work?
Yeah, passes the horizontal line test is something I don't need further explanation for. It is a one-to-one function. I would need further explanation. How can you tell? Because it passes the horizontal line test, it's a one-to-one function. Do you see how that question, that answer isn't good enough because I still need to see how you can see that. Does that make sense? So it is a one-to-one. I'm not arguing that. But it's one-to-one because it passes the horizontal line test. I like it. Or you could even just say the definition of the horizontal line test. Every x has only one y, and every y has only one x, which is why we call it one-to-one. This x goes to this y, and this y goes to this x. They're bonded. Aw. Right? Are you guys cool with that? To be a function, you just have to... So this is a function. Why does this not have an inverse? Because if I said the output is 4, what's the input? You can't tell me for sure. What squared is 4? What number am I thinking about? You're wrong. It's negative 2. I mean, so... that's why it can't go back on itself like that to have an inverse. To have an inverse means if I have the answer, I know exactly where it came from. Which means if this goes to this, if this input has this output, that output can only come from this input, one-to-one. That's why we call it that. I like this. But any way you say it, it's going to be related to horizontal line test being passed. Yeah. Yes?
So I think I'm just trying to be lazy, but for 2, we're asking for the dominion range of each. So for that first function, is there an easier way to do that other than just finding the inverse for the range?
You mean for f of x?
Yes.
So why would that not have an inverse?
No, I'm wondering if there's an easier way to find
No.
range other than doing
No. You don't understand my question. That does not have an inverse. It doesn't. So you can't find it. It doesn't have an inverse. Does anyone know what the 4 through to 60 minus x squared, I mean, it's related to the square root of 60 minus x squared, which would be a circle of radius 4. 4 through to 60 minus x squared is still just the upper part of something freaky looking. Right? So that does not pass the horizontal line test. There wouldn't be an inverse function. But, now watch. So the way that you should do this problem, what was that again? Minus x squared, yeah. So what's got to be true about the inside? It's got to be, to keep it from being complex, it's got to be greater or equal to 0, right? This would be a down parabola, wouldn't it? So then where is it greater or equal to 0 in between its x-intercepts? That's the quick way to do this. You could do some long-ass algebraic way of doing this, and it would be like 4 minus x, 4 plus x is greater or equal to 0. Where is it 0 at 4, negative 4, 0, 0, check each, oh, screw that shit. It's just a freaking parabola. Where is it positive? It's opening down, so it's between its x-intercepts. And what are the x-intercepts here? Yeah, so it'd be from negative 4 to 4 is the domain. Now think about it. Where would this thing be the biggest? It's going to be the smallest at those. Where would it be the biggest? When I'm subtracting the least away from it. See, so you don't have to graph this. You don't have to do anything weird to it. You just got to think about it for a second. So the minimum range is going to be 0, right? And the maximum is going to be 3 times the 4 through the 16 when x is 0. I'm taking away the least. I'm making the whole thing the biggest. So the range is from the smallest to 3 times the 4 through the 16 is 6. So that's where the hell that came from. Is that cool? I like it. Sometimes the G function people don't like. I think it's because when you take pre-calc, some teachers don't even show you that, which is, you have to show you that. That's the rational function. You have to see that. So, I really don't know. Were you all able to find the inverse of that sucker? Did I even do the inverse? I can't remember now. I don't think I did. I think I forgot. Oh, I did. Yay, you did it, Jeff. So watch this, watch this. There's something really interesting about this thing. How do you figure out this guy's range? The domain is easy enough, right? The domain just says the bottom can't be 0. So it can't be -7/6. Yay.
Do the inverse, reswap the y and x.
You can do the inverse, and what I'm about to do, you can't do unless it's very simple like this, linear over linear. What would be the horizontal asymptote? Do you guys remember that horizontal asymptote can be crossed, right? When this is a little bit freakier, it can be crossed because it's not a hard wall. It's just a suggestion. Oh yeah, whenever you get time, start approaching me, right? Just later. In the middle, I can cross you. In fact, you can cross horizontal asymptotes an infinite number of times. You just have to start approaching that value. It didn't say from one side to the other. But this is such a simple little rational function, it's going to have a hard wall there. So what output can I not get? 1/6. Now, if you do find the inverse, eventually you find the inverse. Oh, let me see if I can. What was the inverse for this? I always forget the thing I was going to show you. 5 minus 7x over 6x minus 1. Now, if you would have left this as a y, you could see that y can't be 1/6. The same thing we got up there. Right? If these were still y's, if you rewrite it in terms of x, then you can see the range easy. You can see what y is not allowed to be. Y wouldn't be allowed to be 1/6 because the bottom couldn't be 0 here either. Maybe?
So you're saying there's no way to do it? Like, I'm assuming you're taking the numerator.
You want to try to do it real fast? Well, I mean, like I said, if it's a simple thing like this, you think asymptote. Horizontal asymptote is 1/6. Therefore, you can't have an output of 1/6 if it's a simple thing. If it was more complicated, it might allow it to go through that horizontal asymptote, right? This is just linear divided by linear. Okay, maybe. We're going to stare at each other expectantly for the rest of it. I brought nothing, so I had room for questions. And if you guys run out of questions, then that would be the end of class. But if you guys have more questions, you should ask now. Or if you want to look at more examples of something. Yes?
So on 3.2, on question 42.
Yeah, exactly. We sort of talked about that type of thing.
Yeah.
I was just trying to get you guys ready for that question right there. Do a few derivatives. So they give you this. g of x is x over e of the x,
Yeah.
which I would write as x e to the.
No, it's, oh, okay, it's just the same.
And then they ask you to find this. What does this mean? What does this symbol mean here? What does that mean? Remember, if I have a function, I can take a derivative, I can take a second derivative, I can take a third derivative. If we kept going like this, it would be insane. Oh, with the 80th derivative. Okay, let me get started on it. Oh, shit. So we just said after 3, it's sort of like monomial, binomial, trinomial, shit, polynomial, right? We just said we're not going to give them all names. Holy shit. So we just said after 3, just start putting the freaking thing in a little parenthesis. We know that means 4th derivative. So what does this mean? Nth derivative. So I need a function of n. Really? I need n in there somehow. So how the shit do you do that? Well, like I said, you do a few derivatives. You try to see if there's a pattern. All right, so what's the first derivative of this thing? What do you have to use? Product rule. I like it. So derivative of x times e to the negative x plus x times the derivative, and what's the derivative of e to the negative x?
E to the negative x.
Yeah, negative. So you get negative x e to the negative x. Woohoo! Then you do it again. There's a better way to write this, but I'm not going to do it yet. Take the derivative. Negative e, negative x. Minus 1 e negative x. Minus x e negative x times negative. So it'll be a plus x e negative x. All right, so this definitely has a way I can rewrite this, right? So it's going to be negative 2 e to negative x plus x e to negative x. So far, so good. And then you keep going. You can already sort of see a pattern, can't you? No? If you rewrite this, if I take out an e to the negative x, that's 1 minus x. What if I take an e to the negative x out of here? What would that be? Yeah, it'd be negative 2 plus x, right? So I bet you anything, the next one should become e negative x positive 3 minus x. Can't you already start to see the pattern? Just to make sure you're seeing the right pattern, you do one more, and if you verifies what you just figured out, then you're like, okay, that's got to be it. Then you figure out how to write it in terms of n. So let me help you out a little bit. What if I were to do this? Well, let's see how I do it. Yeah. So then g triple prime of x would be 2e negative x plus e negative x minus x e negative x, which sure enough is 3 e negative x minus x e negative x, which is e negative x times 3 minus x. See, so this was times negative 1 to the 0. This is times negative 1 to the first. This is times negative 1 squared. That's how you get an alternating sign, is negative 1 to the n, or negative 1 to the n plus 1. It depends on how it's going to match correctly. So you see how the signs are alternating. You got to capture that also. That's the part of this that I think would be the hardest part. Is how the hell do you capture the fact that it keeps being one's positive, one's negative, one's positive. Oh, shit. Okay. Yes.
So, like, I understand why it goes from like 2 to 3, but how come that negative x doesn't become like negative 2x or?
It's just the way it is. It's just the way that these things work. I mean, why do you keep accumulating more and more e negative x's? Because this is always going to spit off another e to the negative x. So that's the part that's going to keep growing. This is just always freaking x. It's not getting any more x e negative x's. They wouldn't come from anywhere. There's always just going to be one of them, or a little dude. Now, if I were to, anyway, how do I say this? So see how this is the 0th derivative? Is that cool? Do you understand what I mean by that? So just to really help you all the way, this is like times -1 to the 0. If I were to rewrite this like that, take a -1 out, see how that power matches with the derivative? Power matches with the derivative. And then I want to do it all the way down. So Gn would have a -1 to the n times wherever else. You put an n in the spot of the thing that's changing. See how the second derivative has a 2 there? Well, that kicks so much ass, right? So the nth derivative is going to have a n there. That's too good to believe. If you're going to go on to 280, that type of thing I was just talking about is going to become a huge part of that class. A huge part of the class is all about something called sequences and series, and capturing patterns. And the idea of an alternating pattern is important. So that this might be some of you guys' first taste of like -1 to the n. And it's odd, it's negative, and it's even, it's positive. That's how you capture something, keep changing sign. There's no way for me. Well, my first class is almost too talkative, almost too question. They ask a lot of questions. You guys are